Okay, now let us create the figure that we've seen before, this wonderful bubble chart. And to do so, we will really start from scratch with an empty plot and then add layer-wise all the details needed to end up with a beautiful bubble chart we've seen before. I have here my working script already prepared. I started with a here I am call that you should already be familiar with. The packages we use is the here package. Then we use the data science exercises package only for this dataset, GDP Live X 2007, so that you have something ready-made. And then, of course, we are relying on the package gplot2. The dataset we're about to use has the following structure. So we have the country variable and the continent variable that indicates the country name and the continent to which it belongs. Then we have the three main variables, so to speak: life expectancy, continuous variable, GDP per capita, continuous variable, and the discrete variable population size. All these variables will be used in order to create our plot. But we will do that stepwise to illustrate also the underlying logic of creating a ggplot. And in the first place, what I want to do is just to show you how you can create an empty plot in ggplot2, because this is what you're basically always starting with. So let's call our plot GDP plot, and we create here an empty ggplot. By this, we only call the function ggplot without any arguments. And this is basically what I told you in the video, the creation of the list that is describing your plot. You see here in the upper right, GDP plot is a list of 11. If you look at the list, you see, okay, there are a lot of variables. It's very difficult to read, basically. Fortunately, you don't have to, but this basically shows all the default values that are created when you create a ggplot just as a list. So that's the list, and I also told you that creating plots basically involves two steps. First, the description of the creation of the list describing the plot, which is here, just empty plot so far, and then in the second step, we are calling this list and thereby ask R to render it. So if we call this by name here, after defining the list, then we call it, then we see that R automatically creates the resulting figure in here. Now this is obviously only a gray canvas, and that is because there's nothing that we have defined in here that describes a plot in greater detail. But this is what we're now doing step by step. The next step will now be to specify the underlying data set. Let us illustrate again how to do that. We can again create our ggplot. I will just override this variable here. We start with the ggplot function, but now we are defining the argument data. Here we define the name of the data set that we're about to use, and in our case, this data set is called GDP data. And if we now create the plot like this and then call it again, we here see no change. So we might be wondering whether we did something wrong, but if you inspected this list over here, you would see that the default data set has been defined. But it doesn't change anything in the appearance of the plot. And the reason is that we have not associated any information from the data set to our plot. And we could start doing that by creating certain mappings here. So let us, in the first step, specify the first mappings. And if we go back to the data set here, we see here the names of our variables. And maybe the first thing we want to do is to clarify that R should map the life expectancy on the y-axis of the plot and the GDP per capita variable on the x-axis of the plot. So how do we do that? So again, we start with the name of our plot. I will override it again. we specify the data. That's the data set GP data. And then we want to adjust the mappings. So for the mappings, we only always use this function AES for aesthetic mappings. And then we can start telling R which of these variables should be associated to which aesthetic mapping. So in our case, we want to specify the x-axis and associate it with this variable GP per cap. I always recommend you to do a lot of copy pasting in order to avoid typos. And for the y-axis, we want to use the function liveexp. In order to make this a little bit more readable, I always suggest you using some line breaks in order to make it a little bit easier to read. And if we now create the new plot, we can now view it. We see here that the appearance of the plot has already changed. Not so much, but at least a little bit. Now the names of the two variables are plotted here on the x and y axis respectively, because the names of the variables represent the default labels for the x and y axis. Something we might change later on, but the default name of the variables of the axis is always the name of the variable that is mapped onto this axis. We also see here that some breaks and ticks have been added here and small labels, and that the range here corresponds more or less to the range of the observations in this variable. So we could, for example, have a look at the minimum of GP per capita. It's 277, and the maximum corresponds to basically 50,000. So you see, okay, this more or less corresponds to the limits of the x-axis. If you did the same for the y-axis, you would also see that life expectancy goes from somewhere close to 40 to something close to 80. Again, this is the default value. It might not be the best value to choose for your final visualization, but we now see how the association of these variables with certain aesthetic properties of the plot has already changed the appearance of the plot as compared to the empty plot here in the beginning. As a next step, let us now add the first layer of geometric forms to this plot. So we have defined the x and y axis. Now we want to add points that illustrate the combination of GDP per capita and life expectancy that we see here in our data. So to this end, we can basically copy paste the code from before. And what you will do in ggplot, if you want to add another layer of basically geometric forms or additional information to the list, you use the plus button and then write down the function for the adjustment you want to make. So in our case, we want to add a geometric form. So these functions always start with geom underscore. You already see here a lot of different suggestions. So you see, okay, there are basically tons of different geometric forms you can add. What we want to add is just geom point. So we want to add points. And if we do that and now render our function, we see here that basically the plot more or less stays the same. If you compare it to the previous plot, you just add an additional layer. And this additional layer is the layer with the points. Each point representing one observation in the underlying data set. And this, I guess, is probably the most important understanding that you need when it comes to the creation of plots with the ggplots. You define defaults and then you add layers of information step by step by step. One important kind of information are the geoms, in this case the points, and you add them via the plus operator. If you want to specify something about the points, you can do that within the function of geomPoint. As I said in the beginning, you could have taken all this information here and put it into the geometric point function. Yeah? This would basically create the exact same result. But in our case, since we want to use that for all the geoms that we are about to use later on, we want to keep it in the ggplot function because we want that as a default for all things. Still, we might change things that only apply to the points we want to plot there. So if you look at the data, at the figure that we want to create in the end, you might recognize that the points here are a little bit transparent. Right? So this is something we want to change only for the points. We want to change the transparency. The arguments required for that, you either by name because you've used them a couple of times, or just Google them or ask an AI. So there is this this alpha parameter. It's important. It's not the function. It's the parameter, and you set it between 0.0 and 1.0. So 0.5 would basically 50% transparency. If we now render the plot, we see that now the content of the figure or the inner part of the figures is now 50% transparent. Here, important thing is this argument here is not inside a mapping, so it applies to all to all points equally. If you've written something like that within the mapping, the value for each point depends on the value of the variable. But if you just write it within the function like here, every single point will have a transparency of 50%. If you would link that with a variable name within an aesthetic mapping, each point would have a different a different transparency depending on the value of the of the data set. To illustrate this, we could now add an additional layer of information. So we now want to add the size and color aesthetics. Remember that in the final plot, the sizes of the points was dependent on population size, and the color of the points was dependent on the continent. If you want to add something like this, you need to ask yourself, is what I want to add more like the alpha value that applies to each point or each geometric form in the plot, irrespective of the underlying data? Or is it a mapping that links the value to one of the variables in the underlying data set? So in our case, we want size to be dependent on population size. So we add here size equals pop. And we want the color to represent the continent. So it's both an aesthetic mapping and not a general information like the alpha point. If we now render the whole thing, we now see here that the plot has changed. This is the version before. This is the new one. Now the color of the plots of the points represents here the variable continent, whereas the size of the points here represents the variable pop. You also see that legends are added automatically, but this is something we might want to change in the future. So now we already have a more or less decent plot, but now we might want to change details to make it look more visually pleasing. And one way to do that is to work a little bit more on the points. Like right now, there's a little bit the danger that the points are melting into each other. And we could avoid that by, instead of changing the whole color of the points, we would basically keep the outside of the points in black, but only color their interiors. That basically amounts to changing the aesthetic color over here with the aesthetic fill. That means we are not coloring the entire point, but we are only changing the color of its fill color. But if you do that with the current code, you will see the following. It doesn't work. Yeah? Everything remains black. And this is sometimes a little bit problematic with ggplot, because it just doesn't do what you intend to do, but it also doesn't give you exactly an error. So in this case, you just need to know how the underlying objects are operating in order to get what you want. So here, we are surprised, everything's in black, although we actually mapped the variable continent to the aesthetic fill. So something's wrong. Yeah, and this is something you just need to know. Here, the fact that geonPoint draws points refers to the so-called shape that is used. So shape is also an aesthetic that we could change here. So we could write shape equals continent. Let us just do that and comment this out to see what's happening. So in this case, you now see that the different shapes like pluses, triangles are used to represent the different continents. This is not so useful in this continent. We actually want to keep the fill thing. But what is important about the shapes is that the shapes have different properties. And some shapes, for example, have different fill and color mode, and this is something you just need to look up. So if you go into the internet and you look up, okay, what kind of different shapes are there for geonPoint and geoplot2, you will see that the shape 21 allows you to set a different fill color to the outside color. So if we then write fill continent here within the mapping, and we use color equals black, and we specify shape 21 for every observation. We don't put it into the aesthetic mapping. We put it here to have shape 21, type 21 for all observations. What we will then get is what we initially wanted, right? So we have the black lines outside the point, and we have the fill color according to the original variable.